देखा। अभी नो एक्सप्लेन करते हैं। छोटे।
Good evening, all. Hearty welcome to National Level Seminar on Bits to Billions, Exploring the Frontiers of AI, organized by the Department of Computer Science in association with IQAC from May 13 to May 16. Throughout this event, you will have the opportunity to delve into a wide range of topics from machine learning, empowering intelligence, transforming tomorrow, the future of programming, prologue AI, synergizing big data and AI, illuminating insights and creative intelligence, exploring generative AI. We are privileged to have an eminent panel of speakers from different states who will share their insights, experiences, and expertise with us. In addition to the enlightening sessions, this seminar also provides a platform for interactive discussions. We encourage all participants to actively engage in discussions and share their knowledge. E-certificates will be provided for each session. Participants can attend all the sessions via Google Meet or YouTube Live. Now, let us seek the grace of God Almighty through this moment of silent prayer. Next, I would like to invite Ms. Rashmita of QBCA for welcome address.
Good evening, all. On behalf of Christ College of Science and Management, I extend a warm welcome to Reverend Father James George CMI, Principal, Christ College of Science and Management, Professor S. Adi Lakshmi, Head, Department of Computer Science, esteemed speaker Dr. Jiva Jose, participants and delegates to this prestigious seminar titled Bits to Brilliance Exploring the Frontiers of AI. On the topic Machine Learning, Empowering Intelligence, Transforming Tomorrow. It's indeed an honor to have each and every one of you with us today. We are privileged to have a distinguished speaker who will share their knowledge, experiences, and insights on various aspects of their expertise will undoubtedly enrich our understanding and inspire us to harness the power of machine learning for positive change. As we embark on this journey together, let us opportunities that machine learning presents, and let's strive to create a future where intelligence is empowered and possibilities are limitless. Thank you for being a part of this seminar. I wish you all an engaging and rewarding experience. Thank you.
Thank you, Ms. Rashmita. Next, I invite Ms. S. Adilakshmi, Head, Department of Computer Science for the presidential address. Please, ma'am.
Adilakshmi ma'am, your voice is not audible, ma'am.
Good evening. Could you hear me?
Yes, ma'am.
Okay. Sorry for the delay because I'm connecting from my phone and it was blocked. The mic was blocked. I'm trying to unmute. So, respected resource person of the day, Dr. Jiva Jose ma'am, and my dear participants and teachers. So it is a fantastic evening today. So Department of Computer Science always coming up with a captivating the current trends topics, and we always motivate our students to step ahead from the curriculum, and they have to learn beyond what they look for the regular examination. So that is the main motto, and that we used to insist every time. And bringing a resource person and experts from across the country, and through them enlightening the greatest the topics like AI and upcoming trends. It is really highly beneficial to our students. So thank you, ma'am, for accepting our request, and it is our pleasure to have you today. And I appreciate all the participants who have joined today, and I'll assure you, sure, this particular session, so starting from today to till the 4 days till 16, so you will be really getting enlightening sessions in artificial intelligence. So stay tuned and attend all the sessions which is coming in this national seminar series. So hearty congratulations to all the team and organizing team. So you have done a wonderful job. So in spite of technical glitches, you made it happen today. So hearty congratulations, dear team. Okay. So thank you all. Thanks for the opportunity.
Thank you, ma'am. It's my pleasure to introduce our esteemed resource person for today's session, Dr. Jiva Jose, who currently serves as Associate Professor at BPC College, Tiruvam, Kerala. She is an academician, software trainer, and author of many books. She holds PhD in Computer Science from Mahatma Gandhi University, Kerala, where her research focused on weblog mining. She possesses over 2 decades of extensive experience in the field of education, spanning 23 years and 6 months. During this period, she has completed 3 research projects funded by UGC and KSCE. Her areas of interest are World Wide Web, data mining, cyber laws, statistical modeling, Python, machine learning, and data science. She is a recipient of ACMW scholarship provided by Association of Computing University, New York, Young Women Research Scholars from Developing Countries. She has published 28 research papers in various refereed journals and conference proceedings. Next, I would like to invite Dr. Jiva Jose to start the session on machine learning, empowering intelligence, transforming tomorrow. Please, ma'am.
Good evening, dear participants. I hope I am audible, right?
Yes, ma'am.
Yes, ma'am.
So, first and foremost, let me take this opportunity to thank the management, the principal, and the entire Department of Computer Science for inviting me as a resource person to this seminar. In today's session, what I'm trying to do here is we have only 1 hour, so I will try to share with you whatever little I know, because this is not a hands-on session actually. Okay, so this is my topic: machine learning, empowering intelligence, transforming tomorrow. And as you all know, machine learning is one of the most buzzwords in industry and in research now. And most of you may be knowing that machine learning is actually a subset of artificial intelligence. Okay, what do you mean by machine learning? I hope and believe that majority of the participants in this meet is students. So I need to say some basics, and after that I will go to a little bit intermediate to advanced level, right? So how human beings gain knowledge or information. So mostly from our experiences, right? So for example, I will tell you, suppose when you move out of the home for the first time, a newly constructed home, and you may not be well aware of the steps, okay? So once when you put your leg, what happened is you may fell down, and from that experience you understood that there is a step, or the floor is little bit deep there. So when the next time when you cross the same path, you will be a little cautious, and you will adjust your step accordingly. So that is how human beings learn from their experience. So as far as a machine is concerned, it doesn't have any experience, or it doesn't have any knowledge of its own. So we need to train it, right? So machines can also learn from their past. That is what we see in machine learning. So in simple words, we can say that, we train the machines, and the machines will act according to their previous knowledge available with them. And we coined the word machine learning from that. So if you look at the machine learning, steps, or the activities or the processes that happens in machine learning, definitely there will be a training data, because we need some data to train the machine, right? So we will take the training data, and you will also identify the proper machine learning algorithm. I'm coming to it. So you need to identify what to do first, whether it be classification, or it be prediction, or it be clustering. So you need to identify that. So using this training data, and you have identified the machine learning algorithm, and with the help of these two, you will train the machine. Okay. And you will once you train the machine, what happens is the machine is ready for making prediction, and you will give a new set of data. Okay, so a new set of data, and using this ML algorithm, it will make the prediction. And you can have most of the softwares that make that work with machine learning algorithm, implementation of machine learning algorithms. They provide accuracy also, accuracy of the model. So if the accuracy of the model is not satisfactory, again you will retrain the machine with new set of input data, right? And if it is successful, maybe it is very close to 95, or it is between 95 and 100. It depends on the application that you use. You can mark it as a successful model, and you can use this model in future for inputting, for providing new data and give us the result. So this is a basic working of machine learning. And you may think, why machine learning, right? What is the need for machine learning? You can see n number of applications for machine learning. So when I say machine learning and artificial intelligence, there is a slight difference. I will tell you what it is. Mostly when we talk about machine learning mostly deals with structured data. Okay, there are situations where we deal with unstructured data also, but AI mostly AI can deal with structured as well as unstructured data. So I should say machine learning is, is a subset, as I told you in the beginning, it's a subset of AI. So if you look at the applications, there are several fields. In the field of travel, you can see, suppose, when you have booked a flight, sometimes the flight may be delayed. Based on the previous experiences, an airline can predict how much will your flight get delayed. So that they do with the help of previous data available. You imagine that suppose a particular airlines named X has some 6,000 flights already finished. So they will have in their database, which all flights have delayed, and what up to what time it had delayed. So based on that previous data, it can predict how much a particular flight or upcoming flight will be delayed. So that is one application. Again, this dynamic pricing, you might have seen it if you book an Uber, or Ola, or some online cabs. Sometimes you might have seen the surge pricing, right? The pricing may change. It not only depends on the distance and the time. Sometimes, the demand will be huge and the number of vehicles will be very less. So in that case, it automatically calculates. They have their own equations to calculate that. That also is generated from the previous data available, and they will calculate a price for you that will be always slightly higher than the normal price. Okay, so that is again another application. And if you look at marketing, again, it has got a lot of applications. You can predict how much time a customer will, stay with us. Or churn out means after how many months or how many years the customer will leave our organization. So this is also done with the help of the history of previous customers who have left us. So similar is the case with cross-selling and upselling. Cross-selling means, you might have seen certain two products, two unsimilar products marketed together. Like, for example, like toothpaste and toothbrush. Okay, there are two different products that can be go for a cross-selling. So they understand that, from the previous data available, they understand that if these two products are sold together, they can produce, the sales volume can be increased. So that also they will get information from the previous purchase habit of the customers, like people who have purchased toothpaste has also purchased toothbrush. Maybe 80% of the customers might have such a purchasing pattern. So based on that type of pattern, they can do cross-selling between heterogeneous products. Then upselling is the case with the enhanced quantity of the same product. Like sometimes you can see advertisements like Horlicks or Boost. If you purchase 1 kg, you need to pay only the cost of 800 grams. Likewise, so that is also from the previous purchasing habits of a customer. And if you look at healthcare, again, disease prediction is one of the most important application of machine learning. Like, your hospital will have a database of the patients, like, so many blood tests or so many parameters, they will be stored and in a database. Again, the data is structured there. So based on that, suppose if your data is given, they can make a prediction even without the intervention of a doctor. They can make a prediction whether you will be diabetic, or whether you have the chance of getting heart attack, or whether you are prone to this liver malfunctioning, like that. So many disease prediction can be done with the help of previously available data within the database. So that is very, very important. Again, medication effectiveness. See, when you go to a hospital, you will be given a lot of medicines. So once the medication starts, you even without the intervention of a doctor, a machine learner can say that how many months will you live, especially in the case of diseases like cancer or a transplant. After giving a chemotherapy, maybe 90% might have survived 1 year. Maybe 100% might have survived 6 months. So likewise, what is your chance of survival? So that again, or medication effectiveness, or how much how much people have completely recovered. So for that kind of application, this machine learning has immense potential in healthcare. Again, coming to sales, as I told you, demand forecasting. You can forecast the demand, like how much volume of a particular product will be sold in the next year, next month. So that again is based on the previous data available within the database. At the same time, you can offer discounts that also, based on the data or the purchase habits of a customer, you can apply in the sales field also. And if you look at automation, you might have heard about, this self-driving cars. So gone are the days, I should say, where the car is completely controlled by a driver. But, coming in the coming years, or maybe from 25 years from now, or maybe 50 years from now, all the cars will be unmanned. I should say smart cars. Okay, so when smart cars, it not only depends on machine learning, it has so many other things, like you might have heard about Internet of Things, like, you imagine a world where all vehicles are unmanned, right? None of the vehicles have these drivers. So what happens is your car will be having a software, the car coming the opposite direction will be having a software. And the moment, once you imagine your car has reached a junction, your car has put the indicator to the left side, then the car that comes in the opposite direction should understand, like a driver, that the opposite car has put the indicator to the left side, so that it need to take decisions according. So I should say that system is too complex. It's not that easy. We need the help of cloud computing. We need the help of edge, fog, so many type of technologies for doing this. But I will say, in the coming years, we need to see that kind of transformation where machine learning helps. Machine learning helps in the sense, how as how previously a car has behaved in such a situation, okay, such a critical situation maybe, or such a normal situation it may be. So that will be recorded, all these details will be recorded in the database, and this will be used in future while your car passes through such situation. Okay, again, the same thing with aircrafts and drones, so I'm not going to uh, go into the details of it. Again, if you work with the credit and insurance companies, again, sometimes you will be giving a lot of input to the company for getting a claim. So the moment you give input, you will get the machine will predict whether this claim is genuine or not, or whether this should be given or not. So, and the same is the case with loans also. When you apply for a loan, depending on the age, depending on your job, depending on the place from where you come from, whether you are coming from an urban or a rural or a semi-urban, then whether you are male or female, like with so many parameters it will take. And based on the previous customers, if they were 95% of people of your ages, if faulty, then if you apply for a loan, 99% the machine will say that it is a risk to give you a loan, rather than a human being sitting in front of you and asking a lot of questions. So that is again another application of machine learning. So again, this the horizon is expanding. The applications of machine learning is increasing and improving day by day. Now, as I told you in the beginning, we need to identify what is the life cycle of a machine learning. Okay, so first of all, the most important thing is that you need to define a question. Okay, what should I do this? So this is very important to the students who are listening to me, because academy and curriculum is in total conflict, I should say. The reason is, in curriculum, what we teach is, we will teach the concept. For example, I will tell you a very simple thing like, standard deviation. Okay, you might have learned in your high school classes. So mostly the teacher will be teaching like what is standard deviation, the concept she may be teaching in the class. She will be teaching an equation, and she will be given a set of data, and she will ask you to apply or find out the standard deviation of this data. So I will say there is no challenge in it, because it is very clear. The teacher has already told the task for you is to solve and find out the standard deviation. But when you are into industry, things are totally different. You will be given a huge data set, maybe of 500 columns and 5,000 records. Okay, so you need to identify which all fields are related, or which all fields are noise, or which all fields we need to remove out. So that is the biggest challenge once you move from academia to industry. So as an academician and a software trainer, I would like to tell you, it is the time, now it is the time to train the students for reverse engineering. Like, you should given the data, and you should be asked to find out what can you do with this data. So none of the university curriculum is doing like that, but industry wants the reverse thing. So that is why students struggle when they reach industry. So here also, this is the thing, like, you have to define a question, what you want to find out actually. So that is the definition. And collect data. Most of the time in industry, you will be given a data, so you need not worry about that. And first thing is that you need to visualize the data. When I say data, I'm talking here in this session, I'm talking about structured data, which can be arranged in rows and columns. May it be an Excel file, or it may be a database, doesn't matter. It can be arranged in rows and columns. So visualizing data in the sense, not only plotting the graph. Before plotting the graph, we need to identify what kind of data it is. What kind of data in the sense, whether it is categorical data, binary data, continuous data, discrete data, ordinal data, nominal data, ratio scale data. There are so many kinds of data, right? So you cannot do certain things on a categorical data, but you can do certain things in a continuous data. So looking at the data, for example, I will tell you, if I say salary, you should very easily, you should be able to identify that it is a continuous data because it lies within a range, right? There will be a lower salary and there will be a higher salary. If I say, age also, it is the same thing, but age can also be categorical. Like if age is given as numbers like 1, 2, 3, 4, 5, you can say that it is continuous data. But in the case, like if age is given like infant, child, student, youth, middle-aged, senior, suppose age, it may be categorized like from this age to this age may be given as maybe 0 to 1 may be defined as infant, and from 1 to 3 years it may be defined as child. So in that case, you can say that it is categorical data. So likewise, you should be well aware of the data, only then you can do anything, especially in machine learning and data science. So that is the task. I should say that is the very, very important task in machine learning. And again, of course, you need to identify the algorithm, right? Identify the algorithm and train the algorithm, like whether you want to do, classification, or whether you want to do prediction, or what actually is the task you want to do. It might have already defined in step 1. So we will be training the algorithm with the data that is available with us, and we will be testing whether our output of this training will be a model actually. So we will test the algorithm with a few new input data, and we will collect feedback whether it is apt or not. Like if we are getting a very good accuracy, we can say that, okay, this is fine. We can end up here, or we can use this model, or we can fix this model. Or if it shows only 50%, maybe the training data will be very less, or the data, we need to add more number of data, or there are several reasons for getting low accuracy. So we need to collect the feedback, and we need to refine the algorithm. We need to train the algorithm. So steps from 4 to 7 will be repeated until we get prospectful accuracy, or we get a satisfactory result. And once you get a satisfactory model, you will fix that model and you will be using that model for prediction. Okay. Now, you might have heard about different types of learning in machine learning. So supervised, unsupervised, semi-supervised, and reinforcement, these 4 are, mostly spoken in machine learning. And I should say supervised is the most, most of the time people are working on supervised machine learning algorithms. Mostly in industry, you will be working on supervised or sometimes unsupervised. And if you're working in games, like, games or something, you will be working on this reinforcement. So depending on the application, you will be focusing on which type of learning you are. Okay. So if you look at a supervised machine learning, those who don't know anything about supervised learning, I'm just saying about it. And those who know supervised learning, you simply ignore it. Okay. So you imagine, I will tell you a small story, like, you forget about all the science, scientific principles, everything. Okay. You imagine that a farmer, he has huge apple orchards and mangoes also. And you may be asking whether apples and mangoes grows in the same climate. This is simply a story. So you imagine that apples and mangoes are grown together for the time being. Okay. So, okay, one day he decided, okay, he will do the harvesting manually, and he will take the help of a robot or a machine to do the packing. Okay, to do the packing, like apples should be packed in separate boxes and mangoes should be packed in separate boxes. Maybe 100 apples in one box, 100 mangoes in another, or he need to pack in hundreds, right? So he need to train the machine. So looking at the apple and mango, human beings, we have previous experiences, right? Even in our LKG classes, our teachers told that A for apple, and she will show us a picture. So apple is very clear to our brain. But for a machine, we need to teach how an apple looks like, right? And again, mango also. So what happens is, for an understanding, as I told you, this is like talking to a first standard kid. Like the farmer will teach the machine, okay, apples, it will be of red color, and it has got curved edges at the top and the bottom, and it is having a very smooth and regular surface. So that is apple. Okay, so the farmer will be teaching the machine like that. And again, he will teach the second thing, that is mango. So he will teach like, mango is green and it is having, a thicker tip at the top. And sometimes, the curve will be like the lower curve will be shaped, like, it will be curved. So that is what mango is. So the machine is ready, and the farmer has done a harvesting. So mostly, maybe 95% it has classified correctly, because maybe five has gone wrong. Five apples or five mangoes may have wrongly placed in, the wrong boxes. Rest it was okay. So maybe that is okay. So he was very happy with it. And the next time, what happened was, that time the apples harvested were green, right? So what happened is, it was total chaos for the machine. Already we have taught the machine as apples are red. So when green apple came, what happened is the machine is in total confusion. So what the result was, so many green apple was put into the box of mango, and so many mangoes was put into this box of apple, and there was total chaos. So what happened is the farmer again retrained the machine, like, not only red apples are there, sometimes the apples may be green also. So again he need to retrain, because that casualty he never expected. Okay, again mangoes, it may not be totally green, there may be some yellow shaded or red shaded mangoes. So likewise it will be refined, that training process will be refined. And if you give an apple to the machine, it will very easily say that, okay, whether it is red or green, it is apple, apple is apple. So that time you can fix that your model is okay, perfect. So this is how we train the machine. And as I told you, if you look at supervised machine learning, you can have classification and you can have regression. So mostly, what is the difference between classification and regression? I will tell you, the similarity is classification and regression is used for prediction. So our intention is to do some prediction. But in the case of classification, we will work with categorical data. That is what I was telling you in the beginning. You need to identify what kind of data it is. So in the case of classification, we'll be predicting the classification labels, and we mostly work with categorical data. If the data is not categorical, then in that case, you need to convert it to category. Categorical label, right? For example, as I told you in the beginning, if it is income or if it is age, mostly it will be continuous value, right? So in the case of income, you can say that poor, then, what should I say? Mediumly rich or highly rich or affluent or whatever. Likewise, you can classify according to the income ranges. So only then you can apply this classification algorithm. That you should be very cautious. You cannot directly apply any classification on continuous data. You need to go for this categorization. And in the case of regression, mostly we have to work with this continuous valued data. So for example, I will tell you how regression works is, for example, suppose you imagine that there are two columns, like one column is years of experience and the other column is corresponding salary that you get for the years of experience. So you have a set of years of experience and you have a set of corresponding salary. And suppose I'm giving, an year of experience, which is not there in that. Your machine should be able to predict what will be the corresponding salary for that particular years of experience. So that is possible because of the previously available data. So using the previously available data, you will be constructing a model and your model is ready. And once you input a new year of experience, it will predict what your salary will be. So that for that kind of application, regression will be used. We will look into that again. I am not talking about clustering in this session, but for your understanding, clustering means you will be given the data and there will be no training like thing. So you will be directly giving this raw data to the clustering algorithm, and based on the behavior of the data, it will be grouped into 3 or 4 or 5. How many type of data is available? So for your better understanding, I have given different shapes here. So your algorithm will identify, okay, this is a pyramid, so this should be gone to this group. And you can say this is a cube, so this should be gone to this group. Okay, this is a sphere or circle, so this should be gone to this group. And the output of this algorithm will be 3 clusters, we say. In this case, 3 clusters. So you can very easily identify there are three type of things or three groups of things in your original raw data. Okay. Now, as I told you, I'm not again going to this supervised learning, sometimes semi-supervised learning, and unsupervised learning. That is what we were talking about. Clustering is a very good example for unsupervised learning. And semi-supervised learning is a mixture of these two. Okay, this supervised learning and unsupervised learning. Again, reinforcement learning. So this is again one category of machine learning where you will be using these type of learning mostly in game theory or games, developing games like suppose you can see a robot here and it wants to take the jewel or this gem. So he can move in different directions, but if he crosses a fire, the points should be deducted, or he wants to find out the shortest way or the optimal path to reach here without any hindrances and to pick this jewel. So that kind of learning we say as reinforcement learning. So normally we will be working with unsupervised. In most of the industry projects focuses on this classification or regression, right? Which means we need to do prediction. These things are focused for certain area, right? And if you look at the challenges, once you are into industry, you should understand what all are the challenges in machine learning. Again, the quality of data is very, very important. It is not ready to eat form or ready to use form. The data that you get will be 90% noisy. So you need to clean it. That is a Herculean task. And you need to remove a lot of columns, sometimes a lot of rows, or you need to fill the missing values. So quality of data is a great issue in any machine learning project. And time consuming. Due to this, cleaning of data, you will find a lot of time spending on that. So once your data is ready to use form, only then you can apply your machine learning algorithm or you can train your machine. Otherwise, the output will be biased. So I will tell you a very simple example. Suppose your teacher gives you a Google form for filling your personal data. I'm sure you may be, if she has given everything mandatory, then you have to fill it. And sometimes if she is not particular that it is a mandatory field, what happens is many data you will not be filling, right? For example, PIN code. You may know it. Sometimes you may not be knowing it. Data you may not fill it up because of several reasons. One reason is you may not be knowing it. And one reason is, due to privacy issues. Sometimes if there was a column like annual income, you'll be a bit hesitant whether I should give it or not. Okay. Likewise, sometimes people will not give due to several reasons. Sometimes, some are lazy people. So they will say, what is the use of filling all these things? So many Google forms are coming. So I'm not going to fill this all. So likewise, also people will not fill it up. But once, you imagine that some 5,000 responses are received and many columns are blank or many fields are blank because people have not filled it up. So it is the duty of this data miner or this machine learner to do all pre-processing. Like he or she need to identify so many things. For example, like if one student has the same, city and she has given the PIN code, and another boy, he's also coming from the same city, but he has not given the PIN code. Then the data miner or the machine learner should, use the PIN code of that girl, and it has to replace with in that boy's record. Likewise, so many type of pre-processing we need to do. And again, lack of expert persons. I will tell you, as I told you in the beginning, reverse engineering matters. So when you are given a raw data set, a huge data set, you will be like, putting you in, what should I say? Swimming. Okay, right. Swimming. You have learned your swimming and you have got a certificate, but you have experience only in a swimming pool, right? So, every day you swim in that swimming pool, you know the length, you know the depth. So, how much time will it take to reach the next end. Okay, so that is not a challenge. But once you are in industry, you will be put into Indian Ocean, right? You don't know to which direction you need to swim. There are so many challenges like ocean currents, then blue whales, so many other things you need to face. So you are not, even though you know swimming, what happens is when you are into a real project, you will be facing new challenges. So in that case, you need expert, you should be expert, or sometimes your machine learning result may go wrong because of the lack of experience. So that is again another challenge. Again, as I have already told you, overfitting is again another biggest headache in machine learning. Like, many of the machine learning algorithms capture the noise of the data. So I will tell you a simple example. Suppose you have collected the age of the students, okay, in the class, and by mistake, one student has typed, like, instead of 20, he has typed like 200. By mistake, one additional zero has come. Okay, and you haven't noticed it. You use this data for training the machine. So the machine is not going to identify and say that there is a person cannot have an age of 200. So you yourself or human beings need to identify and correct that kind of noise. Okay, or else you can do some coding and you can say the machine that if age falls between only this range, you can accept this. Otherwise, you simply reject this, or you rewrite with a certain value, or like that. You can tell the machine. Otherwise, what happens is the algorithm captures the noise, and totally it will be biased. So you need to remove the noise. Again, underfitting means the algorithm may not be able to capture the underlying trend. Okay, sometimes. So I will tell you, you can apply linear regression. I will tell you a very simple situation. You can apply a linear regression only if your previous data, when you plot the previous data, only if the previous data follows a straight line, you can apply the linear regression. But not listening to that or not following that principle, what happens is you will be performing a regression, performing a linear regression, and you will get some value, but it will be, the reality will be very much far away from the actual thing. So your prediction may go wrong totally. So that is again one another important thing of underfitting. So again, difficulty in deployment, I told you. I have already told you, like, the example of swimming pool, like, you will be learning all these models and training, testing, everything in a controlled environment. Okay, controlled environment. Maybe you might have used hundreds of records, or there will be only 50 columns maximum. But in the real projects, there may be 500 columns and 50,000 records. So the entire scenario is changed. So you need to be, once you are used to it, you can very easily do that. Otherwise, you will find it again certain difficulties. You will face certain issues when you work with these kind of huge volume of noisy data, especially. Again, as I told you, we train the machine with the help of historical data. I mean, the data which is previously available with us. Again, you need to understand that, the data, the behavior of the data keep on changing. So you also need to update the historical data. Like, for example, if you look at the personal data of a person, maybe 20 or 25 years before, it was, not common that everyone has an email ID, right? Everyone has an Aadhaar number. But now you can see that, everyone will be having the mobile number, the email ID, Aadhaar number, everything. So even the data is changing, or new things are coming. So we should also be aware of that kind of things. Again, another important interesting thing is that the model will be developed by one team, and it will be really applied by another team. So there may be issues. Since both the teams are different, the model developed by the development team, when it is used by an operation team, they may find some gaps or gap areas which need to be rectified. So these are some of the challenges. Again, we will look into this supervised learning. I told you prediction and classification are the two important things in supervised learning. So if you look at, and regression is the major method for prediction. I'm sure if you are into data science or machine learning, definitely you'll be working with some regression problems. Okay. So you can have a linear regression, or you can have non-linear regression. So we will look into it how you can have linear or non-linear regression. Actually, regression means there will be, or we are trying to model the relationship between, uh, you know, one or more independent variables, and there will be one dependent variable. Like most of this, linear regression will be of the form y equals so many x will be on the right side. So y equals that, y we call it as dependent variable, which means it is dependent on so many other x. Okay. So that is here you see dependent or response variable, and you will that y will be dependent on so many independent variables called or predictor variables. So if you look at different types of regression, it can be simple linear regression. There are so many polynomial regression and all. I'm not talking about because we have very less time, and this topic itself is like an ocean. So I don't know where to focus. Okay. So simple linear regression, it can be multiple linear regression, and it can be logistic regression. So I thought what I will do here is I will show you how to identify what regression to be used, at least. Okay. So I will give you some tips. If you are given a raw data set, I'm not trying to teach you all the regression, all the concepts behind. I will tell you how to identify. You imagine that you are given a data set, and your boss has asked or your team lead has asked to do regression. Okay. So your task is to perform regression. So you will be you might have learned so many regressions in your classes, maybe in your undergraduate curriculum or postgraduate curriculum, but you will still find it a great Herculean task to identify the proper regression. So that is what I am trying to give you in the class. So simple linear regression. Okay, we will see how simple linear regression look like. I will tell you a very small example here, and I will use another data set, and I will show you how you can identify it is a simple linear regression. Okay. So as I have already told, you are given a set of years of experience. So this is our X, and this is our Y. So what you can do here is, suppose if this is the data given, what you will do is you will try to do a scatter plot. Okay, if in real-time machine learning, what you do is you will try to plot a scatter plot, and if you find that it follows, the data follows a straight line, you can say that your data set is well suited for simple linear regression. So when I say simple linear regression, there will be only one X value, and definitely there will be only one Y value. But in the case of simple linear regression, definitely there will be only one X value, and you can write or you can define your model like y equals ax plus b, which is the equation for a straight line. Okay, so you just keep in mind, if there is only one x, one y, and if you do a scatter plot, if the data follows a linear path, it is a simple linear regression. So that is a tip for you. So in the case of, I will just go through multiple linear regression, and together I will show you this. Okay. In the case of multiple linear regression, there will be more than one x. Okay, there will be more than one x, and y will be the same. So it will be like y equals ax1 plus bx2 plus c. So that will be the equation for a multiple linear regression. So I will show you a practical example because we don't have time. So I'm not going to do the coding. I will show you the ready-made thing in front of you, how to identify a simple linear regression, right? You see, this is an Excel file or a CSV file. So in this, you have year, month, interest rate, unemployment rate, and stock index price. Okay. And your team lead has told you, you have to perform. Sometimes, not even regression, they will say, you do some machine learning, or you apply some machine learning techniques and do some analysis, go for some prediction, go for the prediction of stock index price. Okay. So that will be, maybe sometimes your client will be totally dumb. He may not be knowing any statistics. He may not be knowing any machine learning. 99% of the time it will be like that. So it is your headache or your challenge to identify what to do. Okay. So what you're going to do here is, okay, in fact, this is a very small file, I should say. Okay. So your task is you have to predict stock index price. So looking at year, month, and all data are continuous. All data are continuous in the sense they are numeric data. There will be a lower value and there will be an upper value, and all other data will be residing between that range. So that kind of data, we call it as continuous data. So here you can see everything is continuous, but going for a prediction, year has nothing to do with prediction. Month has also nothing to do with prediction. If you closely look at, there is interest rate, unemployment rate, and again, the client has already told, I need to do the prediction of stock index price. So prediction of stock index price is if he has given a clue like that, definitely you should understand that it is your why. Okay, so why is your stock index price here? So you need to predict stock index price, then you need to identify which is the X here. Okay, as I told you, year and stock index price doesn't have any relation. Probably interest rate and unemployment rate may be the X variables, but they are the only X variables here. But going for a particular regression, you need to identify which is the most apt regression here, right? So in the case of most apt regression, how can you do that? So again, this is we definitely industry also you will be doing on a trial basis. As you know, interest rate. You imagine that we are taking X as interest rate. Okay. So in that case, what you can do here is I have okay. Yeah. So in the case, what I have done here is I have done a scatter plot. So I hope, I don't know whether you can see my screen. Yeah, this is a scatter plot, right? I'm not going to the coding part because we have very less time. So you can see that in the case, it almost falls on a straight line, a slanting line. You cannot expect all the points to fall on a straight line, perfectly on a straight line. That is an ideal case. It will not happen. So you can, plot a straight line touching most of the points, maybe a slanting line, almost close to 45 degrees. So you identify that interest rate and this stock index price is linearly related. Okay, so I can use a simple linear regression for this interest rate and stock index price. Like interest rate is my X and stock index price is my Y. So this is the data available. So I will be using this interest rate and stock index price. Only I will pick these two columns. I'm not going to the coding part because it will take a lot of time. Normally I go for hands-on coding sessions so that it will be more interesting for the participants also. But this is only 1 hour, so I can't go for it. So anyway, I will pick the interest rate and stock index price from this, and I will give these two columns as the input to my prediction functions so that it will generate a model. Okay. And once when I give, here you can see 2.75, 2.5, something like that. And you suppose if I give 2.6 to that model, it will predict this appropriate stock index price. I hope you understood what I'm trying to do here. Again, you can also try whether your unemployment rate has a linear relation with stock index price. So the thing is, you can see here also there is a relationship between stock index price and unemployment rate is also having some linear relationship, not exactly, but it is having a negative slope. Okay, you can plot a straight line negative with a negative slope. So you from this scatter plot, you understood that both interest rate and unemployment rate is linearly related to stock index price. So in that case, you can go for if you are using only one column, you can go for a simple linear regression. If you are picking up more than one columns, you can go for multiple linear regression. So that is how you arrive at a conclusion that which regression to be applied. So I hope you got some idea about what I have told. Okay, I will talk about one more small regression, that is logistic regression, which is very, very useful because I should say most of the time we need to predict either we need to go with this linear regression or sometimes logistic regression. So how can you arrive at a conclusion that logistic regression is the apt regression for a particular data set? So for that, I will show you another data set. Like you can see columns here like GMAT, GPA, GMAT, that is the exam score, GPA, grade point average, work experience. And based on these three, there is another column called admitted. So actually, this is the data of a set of students who got admission to a university abroad based on their GMAT, GPA, and work experience. So if you see one here, you can see that, a student with 780 GMAT, 4 GPA, and 3 years of work experience got admission. So likewise, you can read out all the records, right? And my intention is, I need to train a machine with this data, and my machine should predict. Suppose if I give a particular GMAT, GPA, and work experience, my machine should predict whether that student will be admitted or not. So looking at the column, this is our last column. This is the column to be predicted. It contains binary values, maybe 1 or 0 or true or false, or I said yes or no. Sometimes if you apply for a loan, you can say, once the application reaches the bank, your machine, the machine there need to predict whether it is risky or not. So there are also only two values, 1 or 0. If it is risky, maybe it may be 1, or not, then it may be 0. So you look at the data very closely. So here all the other three columns are continuous data, but the column to be predicted is binary. So if it is a prediction like that, the better and the best option will be logistic regression. So that is how you identify which regression to be selected. You will be learning n number of regressions, no use. Once you are given a data, again, as I told you, you will be in Indian Ocean, you need to identify. So that is why I'm giving some small tips in this session. Okay. So you will be identifying, admitted is the thing to be predicted. And, so based on that, you can predict. So if you look at, I have given logistic regression here. So once you have done all this, you have trained the model. I'm not talking about confusion metrics. So many other things are here. See, if you look at the accuracy, you can see 100%. Your system is saying that this model has got 100% accuracy. So likewise, you can, decide whether you further to proceed with this model or not, or whether you need to train more with more number of data. Okay. So that is how you work with regression. And when you come to classification, I will just go through classification. As I told you, prediction, you will be, predicting or working with continuous value data, but here you will be predicting categorical class labels. Like, most of the time, I will show you an example here. Age, it's a categorical value. If you look at age, it is not continuous. It is given as youth, middle-aged, senior. It is categorical. Income also low income, low, medium, high. Then student, yes or no. Then credit rating. All these data are given in categorical form, and you want to predict whether this student with a particular age, income, or a person with a particular age, income, and if he is a student or not with a particular credit rating, buys computer or not. Okay. So that is, so in this case, you are predicting the class labels. Okay, you are predicting the class labels. So that is the difference between classification and prediction. And the classification is a two-step process. Again, as I told you, you need to construct a model. Then the model can be represented using if then else rule, or it can be a decision tree, it can be mathematical formula, or it can be neural networks, right? If you go for a decision tree, okay, so it will be like this. Like, it is very simple. Looking at this decision tree, you can very easily understand a person with age less than or equal to 30. And if he is a student, the BICE computer, the value for his BICE computer will be S. And if a person with age greater than 40, and if he is having an excellent credit rating, BICE computer, his value for BICE computer will be no. Likewise, you can very easily read out from a decision tree. So this will be the output of a classifier. And as I told you, classification is a two-step process. So the first step is to construct a model. So you imagine that you are given a set of data here, and this is the training data. And this data will be put to a classification algorithm. Again, you have to identify which classification algorithm it is. And, for example, this is an if then else classifier. So taking or understanding each record, it will classify, like I have given an example here. If rank equals professor, because there is only professor here, or years greater than 6. For years greater than 6, this tenured is yes. So this is the conclusion, or this is the model that it has generated. So when once the model is there, and suppose I'm giving a new data like Jeff, professor with 4 years of experience, it will predict the class label of tenured as yes, because all professors in the training data and all people with more than 3 years, 3 years it seems, sorry, years greater than 6 is yes. But in the case here it is professor only because of the reason that he is professor, it is given as yes, because in our training data set there was only one professor, his tenure was yes. So the problem is, sometimes it may go wrong, because as you have more number of training data, the accuracy will be very high. So always keep in mind, you train your machine with maximum amount of data, so that you will get a very good result. So I think I'm not going to explain all other thing. We are running short of time, so I hope I will wind up today's session here. If you have any questions, I'm ready to share my experience. Uh, okay, feel free to ask.
Good evening, ma'am. Myself, Vijay Lakshmi. Ma'am, can you explain something about deep learning? Deep learning.
Actually, deep learning is more into artificial intelligence, right? Because as I told you in the beginning, I am not a person who is an expert in deep learning. I am a person who is having experience and expertise in machine learning and data science. So mostly I work with structured data, the data of this kind. And when we talk about deep learning, mostly we will be giving images or videos or not unstructured data. We will train the machine. We have libraries like TensorFlow, okay, available in Python, where you can choose which model. I mean, whether it is CNN, RNN. Likewise, you can, depending on your application, you can choose that particular model, and you will be training. Again, the process is the same. You will be training the machine, and once, for example, if you are using images, you will be training the machine with a lot of images. Okay, maybe in the case of fraud detection or something. And if suppose a particular image is caught in a CCTV camera, if that image is already trained, identifying, the machine will automatically identify that particular image, and the machine will say that that person is a thief or something like that. So that data is taught deep learning. Mostly we go with unstructured data like images.
Thank you, ma'am. Thank you so much.
Thank you, ma'am, for your wonderful session. Now it's the time for the Q&A session and feedback. Please feel free to ask any questions or share your feedback to your resource person. You can utilize chat box to ask any queries to the resource person.
So, good evening, ma'am.
Good evening.
Myself, Gifty of First PCA. I found this session very helpful, ma'am. And you have given an introduction on my ML, that is machine learning, and you gave suitable examples. You did Excel and you showed us everything and all the models and how it is applicable, the life cycle that we as a student we should know. I really felt that it is a great session. Thank you so much, ma'am.
Yeah, there is one question in the chat box. Can we use existing AI tools to help us know which machine learning model to use? It will help us to certain extent, I should say like that, but not 100%. Okay, I will tell you a very simple example. Like, if you are a person who don't know anything about data science or machine learning, suppose you have a medical data set with you. Okay, I'm just telling an example. And you may be the first question that you ask to your AI tool or chat GPT will be, what all analysis can be done, or what all machine learning can be done in this medical data set. So it will say so many things, so many algorithms. Then the next question will be, how can I perform linear regression, or how can I perform Maybe like that you will be asking the next question. But the problem with all these large language models as well as this Python is that, whatever data you give, it will create some value, but it may not be useful or intelligible. I will tell you one simple example. You imagine you have a three column like height, weight, and marks of student. Okay, height, weight, and marks. So we are very well aware what is height, what is weight, and what is marks. And if you're asking your chat GPT what all analysis can be done in this data set, it will definitely say correlation first, correlation. So you know what correlation is. So when I say correlation, there should be some relation. You know that, in our statistics classes, our teacher has taught us that height will be positively correlated with weight, in the sense as height increases, weight also increases. That is quite normal, we all understand. But what happens with this chat GPT type of thing is, if you give input or if you pick the code from chat GPT and if you run it in a Jupyter notebook or something else, what happens is there is a function called a ZORR in Python. It will calculate the correlation of all the numeric columns and it will give a matrix like output. So what happens is, looking at the output, if you are not having any statistical knowledge or if you are not having any machine learning knowledge, looking simply at the output and looking Google, and again you will Google, how can I predict this output? Okay, then again your chat GPT will say, if your value is between 0.8 and 1, it is a very good correlation. So according to the result that you got, you are having a 0.8 correlation between your height and marks. Okay, because the system automatically calculates all the correlation between all numeric fields. But if you think it is not intelligible, it's very foolish in the sense, you cannot say that if a person is tall, he will get more marks. You cannot say like that. But your system will say that, according to the value you have given, a person with this much height may have a strong correlation. So in that situation, you cannot 100% depend on this AI tool. The AI tool will help you to some extent, but you need a better understanding of the domain. In the case of height, weight, marks, it is okay. We all know height is not going to be related with your marks and weight is also not going to be related with marks. But when you work with a domain which is totally unaware to you, like a medical data set, you may end up in wrong predictions and wrong analysis only because of your chat GPT. Because it will produce some result and it will say that if these lies between this range or if the value is between this and this, this is very good, but it may be total foolish. So that things can happen. In that case, you need some understanding of the domain and the machine learning algorithms. Of course, it helps to you a lot. Yeah, again, one question. How to begin with ML practically once the basics of Python is done? The thing is, you can go, there are so many tutorials available in the form of text as well as in the videos. But you will get a better knowledge of different machine learning algorithms, how to approach. But, once when you learn something, you should understand the key thing in that. So in this class also, I told you, if you want to apply a logistic regression, the last column, that is the column to be predicted, should be contain binary values. Only then you can apply logistic regression. So that you should keep in mind always. Similar is the case with simple linear regression. So likewise, each and every classification or prediction will have certain characteristics. So that you should keep in mind. You can very easily learn all ML principles just looking at Google. Again, you need to take different data sets. That is the advice to you, because a concept of a regression may be explained with a simple data set. That may be okay for you, but when a totally new and different data set is given, again you will be puzzled which regression to choose. So that knowledge is the most important thing. When you go to industry also, that is the thing that we want. So once you learn the basic thing, then you have to go through these kind of different data sets. There is a site called a Kaggle, you might have heard about. I will type in this chat window. Kaggle provides a lot of data set may be real, they might have filtered certain things because of privacy concerns, but you will get a lot of data set. Or you can again search for certain archives, like you can search like CSV files for performing machine learning, or CSV files or Excel files for performing data science. Both can, I mean, same data set can be used for data science as well as machine learning.
Okay, miss. Thank you.
So I hope the questions are over. Thank you so much for your interactions. I don't know whether I was successful, because for me, according to me, the time was too short. So thank you so much for the coordinators, the head of the department, and Marin Thomas, who have invited me. Thank you once again. And good night.
Thank you, ma'am. Next, I invite Ms. Jashmita of 3rd BCA for vote of thanks.
As we have come to the end of this enlightening session on the topic Machine Learning, Empowering Intelligence, Transforming Tomorrow, as a part of National Seminar on Bits to Brilliance, Exploring the Frontiers of AI, it's my privilege to extend a heartfelt vote of thanks to our esteemed resource person, Dr. Jiva Josmam. Ma'am, your expertise and insights have truly enriched our understanding of machine learning and its vast potential. Your dedication to the field and your willingness to share your knowledge have been invaluable to all of us present here today. Throughout the seminar, ma'am has illuminated various concepts like applications of machine learning, life cycle of machine learning program, types of machine learning, challenges, and etc. We are grateful for your time, effort, and commitment in preparing and delivering such an informative and engaging session. Your expertise has undoubtedly empowered us with the knowledge and inspiration to tackle the challenges and the opportunities that lie ahead of machine learning. I would like to thank all the participants for their active engagement, thoughtful questions, and valuable contribution throughout the seminar. Your enthusiasm has made this event a resounding success. Thank you.
Thanks a lot, ma'am. The session was really awesome. And the examples was no, it was really interesting to relate the things with the concept, because this concept is something like with a real example, it is very easy to match. And I hope, because I've seen the participants list. Actually, the students were stayed connected, and they were so that is really the success of this this event. I'm happy to share about it. Okay, so thank you, ma'am. Thank you so much for your session today.
Thank you.
Dear participants, a feedback link has been provided through the chat box, which will remain active for the next 15 minutes. We kindly request you to take a moment to fill out the feedback form, as your input is invaluable for our continuous improvement. Once you have submitted your feedback, an e-certificate acknowledging your participation will be emailed to you. We will convene for the next session on the future of programming prologue using AI tomorrow at 5:30 p.m. Thank you all.